recording. And so, again, updated D2L, particularly note the rubrics here, which will show you like how each of these projects are going to be graded, right? And this is going to make my turnaround time for the grades here on out a little faster. So basically we have, out of 25, I think most of these are out of 25 points. We basically have 5 criteria with a possibility of 5 points, right? So the glass marble, I gave you like, 1 point, 2 points, 3 points, 4 points, or 5 points. The way to think of these points is very similar to the way you think of Amazon's star review system, right? Like that's kind of how I'm looking at it. It should give you a tally of what that is out of the percentage range. Like if you have like 20 points, what does that actually mean your grade is out of 100 points? So it's, I think 20 points out of that would be 80, right? So 20 out of 25 would be 80. Yeah. So I just wanted to show you that each of these have this. The reason I wanted to show you that is because you are working on these projects. I don't want you to feel like you're working on them blind, right? Like, what is it that I should be focusing on bob and arm, right? And so this is the criteria for them. I uploaded these a couple of days ago. I forgot to bring them up in class. So here they are, and this will kind of give you an idea of how, like, if you are like running tight on time and you're like, oh, I'm just going to go ahead and leave this element out. If that's a whole graded section of it, that's probably not the place to trim back. All right?
Yeah. I just forgot how to drink.
Oh, yeah, that's okay. Got a drinking problem. All right, so what we're going to be working on today is one of the exercises, but I wanted to just spend a little bit of time playing around with simulation, right? And then I'm just going to give you a little, hopefully a little fun challenge to create, and kind of think of this challenge more as like a little test, like a little quiz, right? I'm going to show you a bunch of stuff on how this works, and then I'm going to give you a couple of challenges in this one animation and be like, go out there and try to make that happen, right? So let's look here. Where do I want to start? Let's go ahead and start with a couple of objects. Right. So when I say simulation, I think it needs a little bit of like clarifying about what I'm even talking about. Most of the time when we hear that phrase, we think of like a flight simulator or like a goat simulator. Like that it's this idea that you're going to go into it and have an experience that is similar. Simulation I'm using in here to mainly talk about the animation parts of effects, right? To simulate anything means to try to replicate it through some means, right? And in most cases, how we've been animating so far have been through keyframes, right? I set keyframes and I'm in this direct control of the way this arm moves, right? I rotate the shoulder, I rotate the elbow, right? There are times when you see, let me back off that. So you're in direct control of all of the parts of that arm, right? There are certain things that are difficult to control, right? Fabric is one of them, right? Like, where do I put the controls on this fabric? What if I wanted to take this off and like wad it up into a ball? Like, how do I rig that, right? That's why we need simulations. There are some things that just move in almost any possible way, right? Where would you put the deformer in smoke? Right? How do you create controllers for water? Right? Those things are things that that the way we usually create those in animation is to simulate them. We create a different type of object, and then we let physics or a series of controls be in charge of how those things deform and move, right? So I'm going to show you a handful of different things in simulation, but we covered simulation a little bit in the principles classes, right? What was the projects we did? There were simulations in there. Yeah, the cereal, right?
Oh, duh, I was hoping.
So the cereal, what were we using to simulate the cereal? Yeah, particles, right? And so particles, you can think of other objects that might be simulated through particles. Like we used it for cereal, but like raindrops, maybe. Let's say confetti. Like you want to throw a bunch of confetti because everybody loves throwing confetti. Like pretty much anything that you have a large number of small particulate items in it, right? If you use enough particles, you could actually use particles for stuff like steam or smoke. And for a long time, particles was really the only way that you could simulate stuff like that. Smoke, fire. You would do just a ton of particles that were really, really tiny, so they filled up a scene and sort of made the illusion of fire. We did another effect in that project. What was it? Remember? Yeah, the coffee steam, right? What? So the coffee steam we did using something that wasn't particles. Anybody remember what it was?
I didn't have it, so I have no idea.
You didn't have that? So for that one, yeah, and that one got taught a little bit different depending on which teacher you had for it. For the steam, we used fluids, right? Which is confusing because fluids sounds like it's going to be water, right? And it's not water. It was more like when things move in a fluid manner, right? And so to kind of show you that one quickly, if you missed that one, all of this is going to be under our effects menu, right? And it is, where was this at? Fluids. And then if we make a 3D container, right, and hit play, we get like a little steam there, right? I'm going to go ahead and set this to playback every frame max real time. This is important with any type of simulation, to either be play every frame or play every frame max real time. And if I set this to like 500, you'll see my steam just kind of does something like that. And we can change the resolution of this, like 30, like that. I can also change my auto resize to make it change sizes automatically. And so what we get out of that is this steam simulation, right? And of course there's a little bit of like other things we can add in here, like a little bit of turbulence. Right. And so you can get some really neat stuff out of this. Now, I think it's important to remember that in a lot of this stuff, particles, fluids, water, if you're actually simulating water, those things are going to heavily depend on the render, right? This is how this looks in our viewport. It looks awesome. And then you render it and you're like, I can barely see that, right? There's like a lot of stuff you had to go back and forth with the render on this. Because really what we're doing is we're creating something that's not a solid object, right? There was one other thing that we kind of covered in some classes, mainly when people would ask the question, which is like how to do water. I covered this in some for the bridges, the bridge project. So there are like 3 or 4, I can think of at least 4 ways to simulate water, not just to fake water, right? In Maya. There's the fluids simulator here. There's particles. You can turn a group of particles into a single mesh, and so it feels like this globular thing. Like if you wanted like chocolate syrup all over something, you could kind of do that with particles, right? Or strawberry syrup, whatever kind of syrup is to your liking. And then there's Bifrost, which makes your head explode because it is really freaking complicated. Bifrost is how we would simulate flowing water, right? If you needed to pour water out of a cup and into another cup and get that like flowing water simulation, that's Bifrost inside of Maya. A lot of the effects animation classes right now, they're doing stuff like that with Houdini. Houdini is like a complete physics simulator engine that's a standalone thing. And then there's another one that's like, I'm not going to get into Bifrost. Bifrost is crazy complicated. There's another one just called BOSS, B-O-S-S. And what that's going to do is allow us to simulate like a body of water, like a pond or something like that. And so I thought I'd show you that one really quick. Not necessarily that we're going to use this for the project. I just want to show you a mix of the different things we can do in simulation. So for BOSS to work, I'm going to have to make this a little denser, like more polygons in here, because really it's just kind of a deformer on this object. I'll set this to like 100 by 100, right? And if I go up here, I'm in my effects menu, I go to BOSS and then BOSS Editor. Sorry, let me turn off my symmetry. I don't know why that's on. So BOSS Editor, right? Where are you at? Is it crashing? There it is. Why is this going so? Am I rendering somewhere? Stop that. Yeah, maybe that was it. So this is the BOSS editor. There are two things you can do with this. You can make sort of an ambient wave. So like think of this as like an ocean or a pond, and you just want some ripples in that. And then you can also make an object that sort of floats around and causes like ripples in it, right? So the first thing we have to do is decide on the wave solver, right? So right here is to create a wave solver. This is what I want my wave to be made of. So I'll click on that. I have a wave solver. And then I am going to, if I want to add an influence object to that, let me see if this works first. If I just hit play, I gotta go back to the beginning here. Yeah, that's right. So if I want to add an influence to that, I select this object. Let me go ahead and put some keyframes on here. So nothing really seemed to change. Let me go ahead and add some animation just to show you this. So we put a wave solver on there, and that wave solver is looking for an influence object, right? I'm going to make this sphere my influence object. So with this selected, I select my sphere, and I think it's this button right here, add geo influence to selected water. And so when I click that, now what should happen is as this moves, you can't really see it super well in there, but watch my polygons there as it moves. Really subtly. You see them? Set this down to like 100 so we can watch it over and over again. So we're kind of getting little ripples in there. It's really subtle, maybe hard to see. So the trick to this is I'm going to turn that up a little bit, right? The amount that is deforming it. And so if I go to my attributes, this BOSS wave solver, right? I can turn my wave height up, and you'll start to see it happening now, right? And so now this is just sort of causing these waves to happen in this object, okay? And so you kind of have to control that a little bit more, right? Find the amount of waves you want in this, right? However, what it looks like when you look at it is like a perfect sheet of paper that I'm like creating these ripples in, right? So what we need is a little bit of an ambient ripples in there as well, right? That's what this other button is over here, right? So if I select this same object, this right here, this little blue circle, this is our spectral waves. Okay? So if I click that, now I just get some overall waves in there and my ripples, right? Now, what I need to point out is that this is not necessarily a simulation per se. Like this is kind of more of a deformer that is acting in a simulated way. That's vague. Just recognize that what we're actually doing is manipulating the mesh, not like changing it into a fluid object or something like that. This is just causing this time-based simulation on the mesh. Yes?
Would boss be used for games as well, or is it more so just like video?
I would say that there's probably some, in most cases for games, there's probably some form of spectral wave generator in the engine. Having said that, if the game engine could accept an alembic cache or something like that, you may be able to use something like this to get a very specific type of water. I haven't done enough in effects and games to know for sure how those play back and forth. But that brings up a good question, actually. This is a good caveat, kind of a segue, I guess, to go with this. Is we're talking about simulation because that is part of animation. You'll get into this much more in the effects animation class. And so I really just wanted to show you all this stuff because I want you to have a taste of it, right? For some of you, you're going to get like giddy about this. You're gonna be like, this is so much fun. This is the thing I wanted to do and I didn't even know it existed, right? And some of you are gonna be like, I don't wanna do any of that anymore, right? And that's fine, like that's how it should be. Games is one of those areas where I think too many people are saying, I don't want to do that, because that is actually a hard position to fill. And Katie and I have had this conversation before. Like in the games industry, sometimes effects artists are positions that are like difficult for them to find enough applicants to fill that position. And I think part of that is because there's not a single answer to that question you just asked, right? Like, an effects artist is somebody who is like really like you're a professional Swiss Army knife, right? Like you are, we need a thing to happen and there's no such thing. How do we make that thing happen? And so sometimes, yes, you're gonna make an object inside of Unreal, bring that mesh into, make an object simulation inside of Maya, do an alembic cache of that, bring that alembic cache into Unreal, apply a bunch of procedural materials in Unreal, and combine that with Unreal's particle system. There's other particle generators, like simulation tools, that kind of plug into Unreal, like they're standalone proprietary. And those seem to be like, they change every year. Like sometimes there's, so like kind of keep your ear to the ground on that. Like there'll be like, an engine that basically hooks into Unreal and you use that engine to generate your physics and it creates the particles inside of Unreal or Unity.
But I know Ed Lyle was working with something like NVIDIA, something to create, it's something they use in CFDs, the water.
Right.
But yeah, that's kind of why I was asking, because there's this, and then like what he used is it automatically like generates the buoyancy and all that.
Yeah, and some of that's going to be proprietary based off of like, sometimes you will have needs for a certain game or project that a programmer in-house just creates that. Really what you're trying to show, even in visual effects or in games, is that when the director comes to you and says, what we need is this green static electricity that warps reality around it and causes things to like change. Like they'll try to describe it, and then they'll have like a concept artist draw their vision of it, and you go, "There's not a button for that. I gotta like figure this out and make a thing look like that, right?" So that's really what we're going to see with all effects, right? Like. It's a problem-solving thing for all of those other things out there that is not a character or a bouncing ball, right? How do I make that look real? Now, I want to sort of stop here just for a second because there is it's not emerging, but it's a better way of breaking up some of this stuff. So we have keyframe animation, I'm in complete control. Simulation, I'm in, like, I hit some buttons and I let math take care of it, right? And it tries to do what actual physics does, right? And then there's something called procedural animation. And procedural animation and effects like can kind of cross over. Procedural animation is what we're going to go into next, so I'm not going to delve too much into that. But basically it's using patterns to generate a complex series of movements. And you see it a lot in motion graphics where you got all these like twirly like shapes doing all this interesting design stuff. And we're going to play around with that in the next few classes. Simulation though is still like it's problem solving, and I guess all of it is like that. But if this is something you really start enjoying, the hard part about this is that it's easy to get something. The hard part is when you're trying to get a very specific something, right? If you watch the behind the scenes of the first Incredibles movie, they talk about a scene where Bob comes in with his up to Edna's house with the old suit, and he hands it to her, and she says something like, this is garbage, and then she like throws it in the garbage can, right? And they talk about how long that scene took to create, right? And you're like, well, in real life, that takes no time to do. Right? Just wad up a shirt, you throw it in the garbage can. You may have a couple of takes where you miss the garbage can, right? This took them like months, right, to do that one scene. And it's because like maybe it was flopping around too much. Maybe when they threw it, it didn't fall into the can the way they wanted it to fall into the can. It like clumped too much or whatever. And so that's where effects gets complicated, is that it's kind of like shooting, you ever seen those like trick shots on YouTube, like where they're like standing on top of a building and they like throw a basketball like behind their back and like it goes like a half a mile and lands into you realize that there's like 500 takes of that, right? And like it's like that. It's like you tweak something, you do another take and see if it got close to what you were looking for. And you're manipulating this by adjusting physics parameters, right? So things like ocean, like one of my options in here is ocean depth, and it's in meters. Like, that is not a parameter that makes intuitive sense to us, right? It's like, oh, I understand that waves look differently based off of how many meters deep the ocean is. Like, yeah, I guess I understand that, but I don't know what happens if I change that from 10,000 to 11,000. Like, how to intuitively know that is really just learning and sort of experimenting with the tool and seeing what happens when I change that number, right? If I change that number to that instead, how does my waves look different? Like, really the only thing I'm seeing, and this is sort of in the spectral, is it looks like there's like multiple little waves and then there's kind of these bigger waves, and I think my bigger waves got a little bigger. Like I'm not like, and I have to go back and forth to see what that does. Little bits at a time, you will start to understand what that does, but it's stuff like gravity, right? Like what if like this is 9.8, right? What if I change that to 98? So now my ripples seem to get faster, right? Almost a little too fast, right? So you can smooth it and see it a little bit of a better. So like this is where you actually start to see the divide in what interests people. Some of you are like, ooh, this is fun. I want to keep doing this. I want to change the numbers and see what happens next. And some of you are like, just tell me which numbers to type in, Greg. Right? And that was a hard lesson for me. It was in effects that I had to learn the lesson that your job is to solve problems. I remember Marty Fitzgerald was teaching the effects class I was in. This was in grad school. And he was like, okay, today we're going to make fire. And I'm like, yes, I'm finally going to learn how to make fire. And I broke out a notebook And everything he said was like, okay, set the emitter to 10,000 particles a second. 10,000. Like I was like a secret formula for fire, and then King Louie's going to try to take it away from me later, and I'm going to be like, I love that somebody got that one. And that's not true, because the next time you need to make fire, you need to make a completely different fire, right? There's not a secret series of numbers. And for some of you, that you go, oh, well, I don't want to do that. Right? And I think that's this is why I introduce it in this class, is because if you're liking this, like, run with it, like have fun with this, because this is something that ETSU has a track record of teaching people to do well. Like Marty Fitzgerald, I feel like I'm just like, elect Marty Fitzgerald, like in class. He's not really running for any office, but he is really good at teaching effects. And so, like, if this is something you like, run with it. If you're like, nope, I like character animation, I'm pretty good at teaching character animation. Run with it. Find the thing you like and run with it. So I'm going to stop with this boss stuff today, and we're going to look at a couple of other things that I think are fun. File, new scene, don't save. So first is cloth. Like, cloth is just fun to tinker with from the very beginning. Really hard to control. So I'm just going to create a plane. I'm going to create a couple of spheres, just so we have some stuff here, right? And this plane, again, like, it's still just a piece of mesh. So I need more detail in this if I want folds to happen well. Like, if I just grab this edge, right, and pull it up, it's very faceted, right? So I'm not going to be able to get that to deform very well without more detail in here. So I'm just going to crank my number of subdivisions up to, let's do 50. So 50 by 50, right? So you probably all vaguely remember me talking about this in principles. It's called NCloth. In fact, a lot of the simulation stuff in Maya has the letter N in front of it. Anybody remember what that N stands for? Nucleus. Nucleus was the simulation. Nucleus was the simulation engine that Maya implemented as like their physics 2.0, right? So instead of particles, which was the older legacy version, they made N particles, and that's particles that simulate with nucleus instead of the old engine, right? NCloth is nucleus cloth. And actually, NCloth is where we're going to find a lot of nucleus things, right? You'll also see NHair, which means we can do simulations of individual like strands and use that to drive a hair simulation. There's actually other tools for that now that work really well as well. But I'm just going to grab this plane, maybe scale it up just a little bit, right? And I'm going to go to NCloth and create NCloth. Now when I do this, I want you to watch what happens in my outliner over here. Right? I get this new nucleus node, and I get this NCloth 1, right? Now NCloth 1 is not a visible thing. Right, it's just this like, it's just a node that, I mean, it's like this little dot right there, I guess. But it is not like a new thing that I created. It's like an attribute that lives in this scene that deforms my polyplane that I made, right? Nucleus is another object, and you'll see it. It just sort of sets there at the origin point. We can actually move it around. It just has to be in your scene. If you change the angle of it, I think that affects some things. But this is just this node that says physics now exists inside of Maya, right? And here are all of our parameters for that. At any point when we create any other nucleus objects, it's going to look for that nucleus node to see what's gravity, what's the wind like today. This is the hey Siri, what's the weather, right? I actually expected her to like beep in my pocket and start telling me, because I ask her every morning. And this morning she was like, it's going to be windy, and then it's going to be hot, and then it's going to be cloudy, and then it's going to be clear. And I'm like, all right, Siri, never mind. So, So when I did that, it basically created this in-cloth node that has all of the attributes of the cloth, right? And it created this nucleus node, which has all of the attributes of the physics of this world, right? So stuff like gravity is in here, right? And so if I hit play on this, you'll see that now my plane starts moving, right? Right? All the way down forever, right? Now, there are times when you want objects to not interact with other objects. In fact, like you can think of this in real world parameters, right? My shirt currently does not need to be to have any information about somebody who's setting back Jared's like last or like where he's at, right? Like it's not like he's not here, it's not hitting him, right? So why should Maya be doing the calculations of that, right? And so we get to pick the things that it's going to interact with, right? And we do that by making passive colliders or other colliders, right? We say that this piece of fabric needs to collide with these two characters because it's close to these two characters. Make them colliders, right? Yes?
I don't know if it'd be like a thing to ask more, but when you've been creating characters, is the clothing set on like their model, or do you have to animate the physics of their clothes when they move?
Usually what you do is you animate a character not like without clothes, but like proxy clothes on. And then after you're done animating the character, that goes to simulation, and simulation creates the parameters to make the fabric do what you want it to do. Sometimes you have some controls over that. I just finished animating a character that I can't talk about while the camera's going. But he or she has a giant robe, and they make this gesture with the arm, and that had to be passed off to somebody else to simulate how that robe is going to interact. I basically just turned the robe off and didn't worry about it too much, but I would turn it back on occasionally to see like, oh, it's going that arm's going pretty fast. I don't want it to throw it over his head, right? Like I have to, you kind of keep it in mind and you can adjust for it, but usually that's not something you worry about while you're animating. You plan if you're wanting very specific things to happen with the fabric. And on the higher end of development, they may have some controls for that. Like a shirt that you are going to interact with a lot and do like a lot of this stuff, they may have like a blend between a rig, it's very stiff, and then the like light simulation that happens at the bottom. So you can have a little bit of two different things controlling it. So what we want right now is we want this polygon fabric to interact with these two objects, right? So I am just going to make those in cloth objects as well. Now, if I hit in cloth, it's going to turn those into like balloons and they're going to fall, right? Instead, what I'm going to do is I'm going to make them a passive collider. And so that means that they're still just objects. They're just objects that an in-cloth object can collide with, right? And so when we hit play now, we get this. Now, again, these are just objects, so if I wanted to animate these, I can, right? I can move that up a little bit, right? And then I can make this, let's go and let it sit there just for a few seconds. And then I'm going to animate that kind of moving over to here. Now you don't really see any effect of that yet, right? Oh, that didn't work. Now you notice that when I'm scrubbing here, it doesn't, like the plane isn't acting right? This is one of the reasons we have to set this to real time, right? Is because like, for Maya to know what to make this plane do on frame 10, it has to know what happened on frame 9. And if I just jump from frame 1 to 10, it's like, wait, I didn't get to evaluate those other frames. What happened? I'm just gonna have to take a guess, right? And you know what happens when Maya takes guesses? It usually is wrong, right? So that's why we set it to play every frame. That way it can evaluate every frame. Max real time just means when we play it back, we get to see it at a speed that isn't stupid. Right? So we get this, and now I have some animation on this, and it'll affect it, right? And throws it off. Right? This was also a passive collider, I think, so we can move it over to here, scale it down, flatten it out, extend my timeline to 500. Just watch what happens now. Isn't it? like it's so much fun to like just get it to do something, right? But the hard part becomes, what if I wanted it to stay on that surfboard instead of slide off, right? Then it becomes challenging, right? I have to come up with tricks to try to solve. Now the other thing you'll notice is that I'm just going to go in here. It seems to end about frame 200. It's a good spot to end it here. I'm just going to go in here and play blast this. So there we go. Play it. Yeah, that'll work. So even though I had it set to play real time, all that stuff, like I always play blast it just to make sure, because when I render it, that's the speed I'm going to see it at, right? Like that is the final actual time, right? Or timing of this. And so even though it's like, oh cool, it's like the way it's rippling and like twisting and bending, that feels like fabric. It feels like really slow fabric, doesn't it? Like, yeah, it feels very heavy, or it feels very large, right? And so here comes, like, to me, the single most annoying thing in all of Maya is scale, right? Like, is that ball the size of a rubber bouncy ball, or is that ball the size of a skyscraper, right? I don't know. Like, I just clicked the sphere button and scaled it up, right? And so I don't want to get too deep into this because it gets really number heavy kind of quickly. And I really want to encourage you more to experiment with this. If you think of dropping like a napkin from here, right, versus dropping a sheet that's the size of a football field over top of King Kong, right? That sheet that's the size of a football field is going to feel like it's falling much slower. Now, depending on the situation, it's probably not like falling like inch by inch that much slower. It's a scale perspective thing, right? Like it's still falling like a similar inch by inch ratio. It's just when we're that far away from it, that traveling 1 inch doesn't seem that significant, right? Whereas that napkin traveling 1 inch seems much more significant. And so that's where scale really starts to play into this. Now, ideally what you do is you build everything to its actual scale so you get an actual simulation. The problem with that is different simulation engines think of a unit of Maya as a different measurement, right? And so I believe this is still true. I probably should actually look this up before I teach a class about it, right? In Maya, by default, though, I know this is true, one of these little boxes is a centimeter, okay? Now, being in the English system, that's not always intuitive to us. That's less than an inch, right? That's about a third of an inch, right? If you have to identify it. However, for the physics engine, the nucleus, I believe this is still true, one of those units is a meter, which is like 10 times 10 of a centimeter, right? Like, that's way bigger, right? Which means that sheet I just made was literally, like it was a sheet that would cover this room, right? And that just is really confusing about why Maya doesn't standardize that. So that's just something to notate. that if you want to make this accurate in terms of simulation, think of each of those in terms of a meter. And there's even things in the preferences where we can change how Maya thinks about that. And so that might be the way of going. Right now, like the sort of the quick, easy workaround is that we have some things that are affected by that. Right? Like nucleus right now, gravity is 9.8. What does that mean? 9.8 watts.
Meters per second.
Yeah, 9.8 meters per second, right? Well, we recognize that we're not dealing in meters if we created this thinking it was centimeters. So we can actually just move that decimal point to scale that up, right? If I made this 98 meters per second squared, right? Is it squared? Or is it just 98 meters per second? Anyway, then this simulation is going to look different. So it does that, right? Okay. So maybe 98's a little much, right? Actually, I don't really think so. I think it's actually more of this material is maybe a little heavy. So we also have the features to change in here, right? So we have our in-cloth shape here. There's a lot of different things we can change about this material. We can change its stretchy resistance, right? We can turn that way up. And so now it's not going to stretch nearly as much, and it's going to fall a little faster, right? And that feels more realistic in terms of speed, right? Okay. Now I'm going to do something else. I'm going to delete, oh crap, I didn't mean to do that. I'm going to delete these two objects just because I don't want them to collide with those anymore. And instead of doing this as a, well, one more thing before I move on. These dynamic properties, this is the stuff that you control to get a very specific thing, right? If you want this to feel like a rubber sheet, like this is how you make that feel like that. If you want this to feel like burlap, you have to adjust all of these different things. The bend resistance, the compression resistance, rigidity, right? How rigid is it? There are a handful of presets in here that will get you close. Very rarely is this like 100% like perfect, right? So if I grab this, go to these presets, and I choose chiffon, right? That's going to be much lighter. It's going to deform a little slower, right? It's going to, you can tell it's like being affected by wind resistance a little more. It's also very light, right? Some of these other presets are concrete, right? Let's change it to concrete, which is funny when you think about it, because concrete isn't what I think of as concrete isn't what I like to think of as a fabric, right? But what it is something that can deform over time, right? And so I think it's where I have gravity up so high, it's eventually blowing through the objects it's hitting. But you can see that what it's doing is it's denting it, right? It's like warping it so you can get like dents and stuff, right? This may not be the perfect way to get like a car crash dent, but this is kind of the idea behind that. Or we can change that preset to rubber sheet. I didn't actually realize that was an actual thing. And that's where we get the stretchy thing. A little too rubber sheety for me. Loose, thick knit. That sounds good. So you get the idea of the different types of materials you can make out of this. And you just get a different simulation with every one, right? Now, let's say, I'm going to go ahead and delete these two things again. Let's say that I don't want it to just fall forever. Let's say I want to pin it to something. Okay? I'm going to create an object here. Well, let's just try it with a cylinder here and see what this does. So R, extend this out, right, E. So I'm just going to create me like a little like hinge here, like a little post for it to grab onto, right? So let's say this is what I want to control it, is this plane, right? And right now when it falls, it just falls, right? But I want it to feel like it's sort of connected to this. That's why we have right up here, you'll see these end constraints. So these are ways of pinning it to things. You also notice you can make something tearable. You can make something that you can rip in this as well if you need to be able to rip fabric. So I'm going to do a transform constraint. But the constraint isn't on the whole object, right? If I tried to constrain the entire object, then it wouldn't move at all, right? This is for specific components. So let's grab just like a few vertices over here, maybe like 4, right? And then maybe a few vertices over here. And then I'm going to grab this object, and I'm going to go to end constraint. Where's it at? Transform constraint, right? And so now you'll see that those points are kind of like, they have little dots on there. And when I hit play, now I get like a flag or something like that, like a sheet that hangs there, right? Now I can still make this object something that it could collide with. Like I can still make this, because it's not actually going through it there. So I could go to end cloth and make that a passive collider. And so now when it falls, it even feels like it's like bumping into it a little bit, right? And the cool thing about this is since I constrained it to an object, this object here, I can also animate that object, right? So I can do a little bit of like, let's drag it over there. Maybe drag it up to here. Yeah, it's gonna mess it up for right now, but then we'll hit play in a second. We'll see it. Now, there are also under fields and solvers, there's also this option to create stuff like additional like turbulence and vortexes and stuff like that. So that's really ways of getting wind in here. But Nucleus has some of that built in. If I go to Nucleus 1, you'll see that I have this wind speed and wind direction. Currently, wind speed is set to 0. And wind direction, you'll see that there are 3 numbers here, right? How do you think we know the wind direction from there? First one is X, second one is Y, third one is Z, right? Positive or negative tells us whether it's going positive or negative in the X direction. So right now it's saying it's blowing in the X direction in the positive. And so if I look at this little like XYZ thing in my bottom corner, it means it's going to blow in the like this direction. It's going to be blowing from here this way, right? Toward, like on my screen right now, kind of from left to right, right? And so if I want that wind, all I have to do is go ahead and turn up my wind speed. So let's try it there and see what we get. So now we're getting like a little bit of a breeze in there that's blowing this around too, right? We can also add some noise to that, and it's going to add like a little bit of like turbulence to the way it like. Let's crank that wind speed up. Too much. I always like going for too much and then turning it down. Yay! So the cool thing is I can just change that direction if I wanted to. I could do 1 in Y, and it's going to try to blow it straight up. It's kind of interesting. Or I can do 1 in Z. Yay! And again, I can turn that up and down as much as I want to get. Now again, all of this is still going to be based off of what type of material this is, right? If I want to change this to chiffon or t-shirt, right? I'm going to get a little bit of a different, wait, did I change that? T-shirt, replace. Right. So T-shirt's going to like have a little bit more ripple to it, right? And with that direction, I can add a little bit of two directions to it if I wanted to. So for example, right now it's all like one in the Z direction, but I could add one in the X direction too, and now it's going to sort of blow it at an angle, right? And I believe this is true. I think if I make this less than 1, like if I make this 0.1, it's a little less in the X, a little more in the, so. Yeah, so I'm still getting a little bit of X, but not a ton, right? Okay, is this making sense? Okay, here's the annoying part, is if you send this to the render farm, you're just going to get this thing that explodes. If we need it, like once we get this to render the way we want it, or to simulate the way we want it to, we have to save that information, okay? In terms of, the best way to do this for Fabric is to do a cache, C-A-C-H-E, okay? This confuses a lot of people. A cache is just a way of saying, I like how that looks, I want it to always look that way, right? And so you just do this before you render it, right? Like you're simulating it out, you're like, that's what I want it to look like, I'm gonna create a cache for it, right? If you don't, then when it goes to the render farm, it's going to send frame 10 to one computer and frame 15 to another computer, and frame 15 is gonna be like, what did 14 look like? And 14 is gonna be like, I don't know. Like, and so it's just gonna end up a mess, right? It's gonna get this like, some of you probably saw that with your serial simulation. If you tried to submit, it just like popped everywhere, right? And it's because it didn't know where to find it. So the way we're going to do that is if I select this, I need to go ahead and set a project here. So I'll just go ahead and do project window. I'm going to create a new one on my desktop. Fabric test. Set that on my desktop just so I can show you. Bless you. Accept. So what that did, you should probably already know this, but that just created my Maya project folder, and then I can go File, Save Scene As, Fab. So if I go to in cache right here with that mesh selected, say Create New in cache in Object, and go to my Options box. You'll see what it's going to do is it's going to go to my Fabric test folder, and it's going to create a cache in cache fab file for this piece of fabric, right? So I'm just going to say create, and what it does is it simulates the whole thing, and it's really just sort of making a text document for every frame that says each of the vertices are at this location, right? And that way it knows exactly how that should look. Now the cool thing about it is after you've cached it, I can scrub back and forth in my timeline and it works, right? But if I change any of these values, nothing changes. It's kind of like I've frozen it into this simulation, right? And if I go to my, my desktop and look in that file, my fabric test, cache, in cache, fab. There it is. There's all of my in-coth shapes. So each of those represents one frame of animation. So the reason it wasn't working the reason it sometimes doesn't work in the render farm is because you didn't upload these files or you didn't create these files. If this is up on the network too, it will render on the render farm fine. So that is the other thing to think about. Okay. Going to go over another thing. I know, is your brains full? Like, are you feeling like we're hitting capacity? You can do this. You got big brains. I believe in you. I believe it. You know that like apparently proportionally the size of your head says something about the size of your brain, and you all have reasonably sized heads. So I have confidence in you on this. We can do this, right? So I'm going to do a new scene entirely because I'm wasteful like that. I'm going to show you a completely different effects simulator that also lives inside of Unreal. I'm sorry, of Maya. So the thing about what we just did was to create an object that was going to warp all over the place, right? And that's hard to control, right? Sometimes that's not what you need to control. Sometimes what you're needing to control is thousands of tiny objects, right? That are all obeying gravity. A good example of this is if you have like Iron Man crashes through whatever building the Hulk threw him through, and all of that debris, all the brick, all the chunks, all the glass just goes flying everywhere, right? That type of simulation is called rigid body simulation, right? That is rigid body simulation. So that's hard objects, like solid objects, right? Maya has a simulator for that as well. And even though it's a little different, and even though it's got different names, most simulation kind of has a lot of similarities between them. So I want to show you this and give you a little bit of information about it, and then I'll kick you off onto the project and give you some time to just kind of explore this, or the exercise. So what I'm going to do is I'm going to go to Windows, because under Effects, what I'm looking for up here is something called Bullet. And you'll see that it's not there. I'm just always used to it not being there because it hardly ever seems to load correctly. It's like how the Arnold renderer sometimes doesn't load correctly. So if we go to Windows, Settings and Preferences, Plugin Manager, we're just going to turn on anything that says Bullet. Usually it's this ABC Bullet MLL. Right? And then there's Bullet MLL here. I think that is all we need. And so now you'll see that there's Bullet, right? And so we got an active rigid body and a passive rigid body. There's actually another kind as well. You'll also see ragdoll in here, which is something most people think of in games, like when you shoot a character and they die, instead of having animated death animation, they just turn on the ragdoll so the character goes limp and falls over. And it's usually way overdone, and your character goes like flopping around your scene. It's terrible. So that's one of the things you can do. We're not going to do that. It has a little bit of like pseudo fabric animation too. It's called soft body simulations, and that's like if you're dropping something squishy, like a ball or like a blob of something. It can kind of simulate a little bit of that as well. But what most people use this for is to simulate huge numbers of solid objects, right? So I'm going to show you a couple of these. Actually, sorry, that was my wife. Let me text her back and tell her. Okay. So let's grab a couple of these and go to Bullet, Create Active Rigid Body. Okay. And I don't know what that's, did that work? Okay, it seemed to work. Okay, so just like the fabric stuff, it didn't really, it's not colliding with anything. So if I grab the floor, Bullet, Passive Rigid Body, and so now what we're going to get is physical objects that kind of crash down on each other. Okay. I realize we're kind of pushing it to the last minute of class here, and we only have a few of this to try out. I'm still going to go ahead and kick you off on the project, but I think I'm going to give you an extra day on it. I think the next class period will be a Word day. I was hoping to get done with this a little earlier. So we could talk a little bit more when you have questions about it, but I want you to get started on it. Let me show you what the project is. File, new scene, don't save. Up on the network, under the submission or resources folder, we have this SimBots, right? Now I'm going to go ahead and copy that entire folder to my computer. You should too, because it has a bunch of textures with it. And I know one of the questions I'll get is, why are my textures not showing up? Because you have to set your project to it first before you open it, right? So go to Maya, File, Set Project, and it's Simbots, Set File, Open Scene, Bots 01. It's actually one bot. I don't know why I put the S on there. So don't save. So this is what you're going to get. It's a bunch of nothing. Look at that. What's happening?
I think Maya's done for the day.
I think Maya died. I think you're right.
She's dead.
Oh wait, there it goes. It did a something. Ugh. So close. There we go. File. Why are you being like this? There. File. Set my project again. Some bots. Set. Scene. Give it a second to load up. There it goes. There's actually a lot of stuff in this scene. There we go. So we got an entire city here, right? And we got this little guy here, or girl, and he's just adorable. Look at him.
He looks miserable, right?
He is. He's sad. It's because he's in this giant city all by himself. Or maybe he's an assassin bot, and he's just on his way to do a mission. That's kind of up to you, really. So the assignment for this one is, I'm just giving you something that's moving. I'm wanting you to play with some physics. Right? I'm wanting you to play with some simulation. So here's what I'm wanting you to do. If we go to, do I still have the D2L page open? There we go. So if I go to the assignments, oh, I already have it open. Yay, look at that. I planned ahead. So exercise 3. Some elements are too complicated to be easily controlled by keyframes. This exercise is a chance to explore some of those elements, right? So using the Maya file provided, add a simulated flag to the robot and have the robot crash through a stack or wall of other objects, such as bricks, bottles, cans, whatever you want to have in there. You don't have to go nuts. You don't have to do any awesome texturing on it, but if you want to, you can. If there's some model you have from some other class, yeah, do that. Bring in half a dozen of your, not half a dozen, bring in like 100 of whatever bottle you made for the bottle and ball scene in the project, or maybe your cereal boxes, right? And have the robot just crash through them, right? So we'll talk a little bit more about that in class. I have a feeling you all have some issues with it. Probably what will happen is early next class period, I'm going to kind of go through it and do a, what I like to call like a speed run. And basically what I'll do is I'll be like, watch me, I'm gonna do it really quick. Now you go do it. And that way you can kind of have an idea of what it is I did. And that way I can test it out and make sure that I see any pitfalls that you may come up with. So I'll do that for maybe like 15 minutes at the beginning of class. Especially if people seem to be having issues with it. But go out and try it. I think we covered enough today to where you could probably do this without me even going through that. But I'd like to give you a little bit more work on it, right? Now, I think this is, like, I haven't made a flag in there. I did give him a convenient little flagpole that kind of hangs up out the back here. And so you can just make whatever flag you want to and hang it from there. Maybe you're from a different state, you want to do that state. I'm sure it's going to be covered in memes. Like I've done this before, I know how this works. So whatever meme flag you choose, as long as it's not offensive to anyone. Like let's keep a minimum of middle fingers flying on this one. So I think this is also a fun chance for you to, kind of toy around with this, right? See how you can make that look. Do you want it to look like really like billowing in the wind, or is it just kind of a droopy flag? Is it one of those little triangle flags like Cubs win the World Series pennant thing, like whatever. And then somewhere along this way, he's just traveling forward. He's a robot. He doesn't care. He's not going to go around that stack of Dr. Pepper cans. He's going through them, right? And it'll just be a quick way of doing that. Now this one is to be rendered, but we're going to render it a little differently because this is viewport 2.0. Like it comes out okay, right? And so you can just render it through viewport 2.0. It's effectively a play blast, but also if I hit the, oh, go away, I don't want you. We'll talk about viewport 2.0 tomorrow. So, so yeah, that seems like a great place to end. Yeah, basically, viewport 2.0 is like a game engine, and we can render okay through there. And so rather than have you render every frame, you're welcome to render every frame in Arnold if you want to, but rather than have you do that, I'll let you kind of do a viewport 2.0 render.
Do you have to move the robot around, or does he just use the cycle that he's been given?
Oh no, you can just use the cycle he's been given there. The other thing I will say to look at in that write-up is something I'm going to kind of start making consistent. Not across all of them, but at least in this one. I want to see at least 3 camera angles on this too. So, like, I think it was Katie, somebody said like, oh, why is he so sad? Is he sad? Is he like wild-eyed? Is he drunk? Like, what's going on? And see if you can show me some of that with the camera. Like, how can you convey that this robot has gone insane, or whatever it is you want to tell me? Is he lonely and looking for his friends, or is he an assassin and looking for his enemies? Right. So, like, yeah, I know that sounds like a challenge with cameras. Give it a try. See what you come up with. And right now I have this set for October 4th. We're just going to go ahead and extend that till Tuesday, the 9th. So, yeah, I want to see. That kind of screws up our. Timeline a little bit, and I think what will end up happening is the MASH project will either go over spring break or we'll start it after spring break. We'll talk about that more. I just want to kind of tinker around. Fall break.
There you go.
Spring break. Yeah, 6 months from now. We'll think about it then. All right, y'all. Have a great day. I'll upload this video to YouTube here in just a second. Yes. Yes. Let me go ahead and stop this video and upload it really quick first so I don't just have a huge empty spot at the end.